studying force by examining simple machines. One of the most important forces for simple machines is gravity. Our understanding of gravity helps us understand the world around us. Now, scientists are using it to study antimatter. Antimatter is matter with its electric charges reversed. Protons are antiprotons with a negative charge, and electrons are positrons with a positive charge. Particle accelerators, like those at CERN, are able to make antiprotons and positrons, which means they might be able to make antimatter. Just last year, scientists were able to make antihydrogen. They can't contain it for long, but using their understanding of gravity may help them understand more about antimatter. In 1928, Paul Dirac wrote an equation that was actually a question. X squared equals 4. This equation has two possible answers, 2 or negative 2. This equation is so important because it joins quantum theory and special relativity. In his equation, Dirac postulates that antimatter may behave according to the same laws of physics as regular matter. Scientists are using the knowledge of gravity to prove this theory. When antimatter and matter meet, they disappear in a big flash of energy. This is why it is so hard to contain antimatter, and why it is so hard to study. The Big Bang should have made equal amounts of matter and antimatter, so why do we observe more matter than antimatter in the universe? These are the questions that they're trying to solve in the AGIS experiment. The AGIS experiment, which scientists are conducting, will help us figure out more about antimatter by subjecting it to gravity. People from all over the world are coming together to work on this project. Scientists are using the antiproton decelerator to create a beam of antihydrogen atoms. The principle of universality of free fall is the law that states that any object that falls from the same height at the same time falls at the same rate. In other words, gravity has the same effect on each, given variations in air resistance. Scientists at AGIS can create a beam of antihydrogen atoms, which they shoot horizontally at a target, and then measure the variations of where it should be and where it hit, given the effects of gravity. They measure this distance with a Moray deflectometer. Here's a diagram of one. They shoot a beam of antihydrogen atoms through these pinholes. It then hits the target here, which is photosensitive paper. What also gets caught in these pinholes is photons, or light, which has no mass and is not affected by gravity. So when it goes through, it hits where the antihydrogen atoms would have hit if they were not affected by gravity. The scientists then measure this distance and find out how gravity affects antimatter. Scientists then use this information to venture into the workings of antimatter and find out more about our universe.